Welcome to this video on the topic of matrices. In this video, we'll be having a look at how we can perform matrix multiplication on square matrices. Now, matrix multiplication is simply the multiplication of two matrices. This process is vastly different to what we saw in the previous lesson, that being scalar multiplication. Rather, matrix multiplication requires a number of steps. In short, it's going to be the multiplication of entire rows against entire columns and then the summing of results simply to calculate singular elements or members within a matrix. Now, looking at something more tangible, if we turn our attention to the models we see over here, we've got matrix A, B, and C. And what we can see on the right here is that matrix C is defined as the multiplication of matrices A and B. Now, what we're going to investigate with this example here is how we can calculate individual elements, so elements C1, 1, 1, 2, 2, 1, and 2, 2, as defined by the multiplication of matrices A and B. Now, looking at the first elements, we're going to get C1, 1, followed by C1, 2, C2, 1, and finally we're going to get C2, 2. What I'm going to do without explaining is firstly I'm going to show you the calculations involved for calculating C11. Now this is going to look really confusing. However, once I've done the first two calculations, I'm going to come back and explain what's going on. So looking at the first one, C11, it's going to be a result of A11 multiplied by B11 plus A12 multiplied by B21. Now C12, this is going to be a result of A11 multiplied by B12 plus A12 multiplied by B22. Now, what you've probably gathered by now is by looking at these equations here is that I pulled magic numbers from thin air. And you'd probably be right to think that because matrix multiplication is a little bit complicated when you see it for the first time. However, there is logic to this. The way in which this works with matrix multiplication is the first factor, so matrix A, what we do is we scan across the rows. Then for matrix B, we scan down the columns. Now, deducing the factors, I'm going to go A and A here, so A11, A12. These align across the first row of the matrix. For factors B11 and B21, these align across the first column of the matrix. Multiplying these together, they're going to give us the first element, so element 1, 1 in matrix C over here. So matrix C is the product of the first row and the first column, or I should say element C11 is the result of the product of the first row and the first column of matrices A and matrix B. Now, the way in which we deduce this, for the first element we go A11, so 1, 1, multiplied by B11, so A11, B11. Hopping across, we go plus A12, so we're moving across the row to A12. Then we're moving down the column, so B21. This yields C11. Now for C12, once again, we're still in the first row because look, we're in the first row here. So we're going to go A11 and A12. So still the first row here. However, what we're operating on is in the second column. So C12 is in the second column. So we're going to use the second column of our second matrix. So B12, B22. And thus summing them together, we get the result for C12. Now, completing the pattern, we're going to use this color. We're going to start using the second row of our matrix A. So to define C 2, 1, what we're going to do is we're going to go A 2, 1, followed by A 2, 2, as seen here. Following the pattern, we're going to go for the first row in column B, and we're going to go B 1, 1, B 2, 1. And this will give us our element C 2, 1. So notice the color coding pattern we have here. So second row, first column, first column. Notice how they're multiplied together. Following the pattern C 2, 2, we're going to go second row A 2, 1 multiplied by B 1, 2 plus A 2, 2 multiplied by B 2, 2. Color coding this A 2, 1, A 2, 2, B 1, 2, B 2, 2. Thus completing the pattern. What we have here is called matrix multiplication. Now, one thing that should be noted with this particular process here is that dependent on the arrangement of A and B, the result you're going to get is going to differ. So what we can say is that the results or the matrix multiplication is not commutative. That is, order matters. As such, AB does not yield the same result as BA. As a result of this phenomena, we usually have a convention in which we can communicate the order in which A and B are multiplied together. A is post-multiplied by B, and secondly, B is pre-multiplied by A. So quite a lot of information here just to get get your foot in the door of matrix multiplication. But with a little bit of practice, this comes naturally. Now, before we end this video, what we'll do is we'll have a go at doing a few examples. So if we go down in example 1 here, we want to be able to multiply these 2 by 2 matrices. So we've got order 2 and order 2. As a result, the multiplication of these 2 matrices is going to yield a third order 2 matrix. Now, performing this multiplication, and I'll just color code my rows. So row 1, row 2, followed by column 1, column 2, like so. Now remember, for the first, so A, which we're going to be pre-multiplying B by, we go across the rows, and for B, which we're going to post-multiply A by, we're going to go down the columns. Now this is going to yield, for the first element, we're going to go 3 multiplied by 5 plus 4 multiplied by -3. Now for the second element, we're going to go 3 multiplied by 2 plus 4 multiplied by 6. For the element 2, 1, we're going to go 5 multiplied by 5 plus 2 minus 2 multiplied by -3. Notice that I actually do have to think about this. Now, second one, we're going to go 5 multiplied by 2 plus -2 multiplied by 6. So this should take your full concentration to be able to do without making mistakes. Color coding this up, and then closing the matrix off so it's nice and neat. Next step is we want to do the calculations. So we're going to go 5 3s are 15, plus 4 times 3 is 12, but it's negative, so we'll get -12. Then next one is going to be 3 2s are 6, plus 4 6s are 24, 5 5s are 25, plus 2 3s are 6, both of them are negative, so it's a positive, 5 2s are 10, plus 2 6s are 12, and it's negative 12. Completing this, 15 take 12 is going to be 3. 6 plus 24 is 30. 25 plus 6 is 31. And 10 plus negative 12, that's just going to be minus 2. Like so. So we get an answer of A and B, or AB is 3, 30, 31, negative 2. Now to verify the results here, what I'll use is my technology. I'm pretty error prone when I'm doing these, but most people are given the tediousness of these calculations. But it's still important to do a number of these so you know the process involved. Alright, so what I'll do is I'll bring up my calculator and I'll put in the matrices. Going to Option F2 for matrices. Then we're going to we'll do parentheses. And we're going to go Mat Shift Alpha. And then we're going to go Mat Alpha B. Multiplying these together, we indeed get the answers of 3, 30, 31, and minus 2. So using technology, we're able to verify that the calculations done by hand were correct. Now, let's step it up and let's go for a 3 by 3 matrix. Now, this is going to bring a whole suite of new problems in that, firstly, we're dealing with quite a large amount of data here, more than we're dealing with here. Now, the trouble with these is being able to have enough space on the page. So first thing I need to do to be able to enter this question is I need to condense my working out to something a little bit more feasible. Lucky for me, I can zoom in. But lucky for you as well, if you're doing this on pen and paper, you'll have extra dexterity. It's much harder to do when you're doing it on a stylus and computer. Alright, now the same principle applies here as to what we were doing before. What we're going to do is we go across the rows, like so, and we go down the columns, like so. Always draw your arrows in as well, just to remind you. Now, computing the first element, we're going to go 1 multiplied by 1 plus 2 multiplied by 0 plus 6 multiplied by 1. That's our first element. Second element is going to be 1 multiplied by 4 plus 2 multiplied by 2 plus 6 multiplied by negative 3. Going for our fourth element, or I should say our third element on the first row, we're going to go 1 multiplied by minus 1, 2 multiplied by negative 4, and then plus 6 multiplied by 0. So just checking, 1 and negative 1, 2 and negative 4, and 6 and 0. So that's our first row. So remember, same principle, just more calculations to do. Going down, we have to go for this orange row here, and we're starting back with the purple row. Alright, we're going to go 5 multiplied by 1 plus 0 multiplied by 0 plus then 3 multiplied by 1. Noting the pattern, all I need to do is go 5 by 4 plus 0 by 2 plus 3 by negative 3. Moving along, 5 by negative 1 plus 0 by negative 4 plus 3 by 0. So hopefully by now you're starting to see a pattern emerge. Now we're going to go negative 2 times 1 plus 7 times 0 plus negative 3 times 1. Alright, and what we've got are all of the calculations we need to perform to be able to calculate each individual element. Now putting this together, alright, and now I need to crunch all the numbers. So this should be our result to the multiplication of C and D as seen here. Now verifying I haven't made any errors in here, we'll bring up our calculators and I'll throw in the values. So we're going to go alright, moment of truth, and multiplying these guys together, we end up with 7, negative 10, negative 9. See the 4 and 4 and the negative 18. Negative 9, 8, 11, negative 5, negative 5, 15, and negative 26. So what you can easily see is because you're doing so many computations here, it's very easy to forget negatives like that, or even make errors when you're doing these computations here. But it's just important to be mindful and carry on. So in summary, what we had a look at in this video was how we can do matrix multiplication on square matrices, so ordered or matrices that have the same rows as columns. We looked at this algorithm here. We commented on the commutativeness, so AB is not equal to BA. Then we had a look at some terminology of how we can explain the multiplication of A and B, that being A is post multiplied by B and B is pre-multiplied by A. After all of this terminology and theory was out of the way, we had a look at these two examples. So we multiplied a 2 by 2 matrix and a 3 by 3 matrix, as well as verified using technology. So what I recommend with this particular subject matter here is make sure you're practicing quite a few, because in the next lesson we're going to be having a look at how we can multiply matrices that are no longer square but rather are rectangular.